Now we are doing rules for the formation of image. The first rule says the ray, you can see 3 points P, F and C. All together when they are combined it forms a principal axis. So the ray which is coming parallel to the principal axis, that green light, after it strikes the mirror, it will pass through point F. This orange color light, this is the reflected light. So the ray which is coming parallel to the principal axis after reflection passes through focus. Same you can see here in case of convex mirror. The ray will strike the mirror, but since that is the back side of the mirror, so we will show it with the dotted line, because light is not passing actually through there, it is reflected back towards the same side. You can see the orange light, right? The second rule says, this is just the inverse of the rule 1. Here, if the ray is passing through focus, after striking the mirror, it will become parallel to principal axis. You see here a light passing through point F. After it strike, it is becoming parallel to this principal axis. Can you see this orange parallel line, which is parallel to dark brown line? Same rule is for convex also. The rule will not change. So for convex mirror also, you see there is a green light coming from the top. On the back side we will show it with the dotted line, but it is passing through, that means it is passing through F. Now the reflected light actually is the line which is parallel to the principal axis. Clear? The rule 3 says, if a light is passing through the center of curvature, if it is passing through C, after striking the mirror, it will retrace its path. That means it will go back with the same path. You can see with this another line, dark line. This was for concave mirror. For convex, again the rule is same. You see here the ray, you can see again with the green light. This is incident light. Now it is passing through center of curvatures. Remember again the back side we are showing with the dotted line, and it has retraced its path. The fourth rule says, if a ray of light is striking at point P, that is the pole, so it will reflect with the same angle. That means this principal axis here is acting as normal. So the spherical mirror act as a plane mirror. Same for both the cases. So students, please practice. So now we are starting with the image formation in case of convex mirror. So here you can see an image of a convex mirror. So first what we will be doing, for convex mirror we have only two cases. First, when the object is kept at infinity, and second, when object is between infinity and pole. You see in the towards the right side of the pole, we cannot keep any object because that side is polished. When you stand in front of mirror, you stand always in front of the mirror, you never stand behind the mirror, right? Similarly here also we will keep the object towards the left side. So you see we have so to get an image formation where we are keeping the object, we are imagining the ray of light to be coming from infinity, that means very far. So this ray of light is incident on the mirror. So the ray which is, we have just now done the rule that the rays which are parallel to the principal axis, after striking the mirror, it will pass through focus. So but the focus is behind the mirror. So what we will do instead, first we will show the reflected light. The reflected light will go back in the same medium. You can see here with the yellow light. But what I'll do, since the rule says it should pass through the focus, I'll draw it either with a dotted line or I'll use some light color to show you. When you are copying in your notebook, you put a dotted line for this light color, light blue color. which is passing through focus. See this light, right? This light, blue color light, you show it with the dotted one. Now I cannot say the image is formed at F. So what I'll do, at least two reflected light should meet to get an image. So again I'll take another ray of light which is coming parallel to the principal axis. This is called incident light. Now again it will be reflected back. After it strikes, it will be reflected back. So this is your reflected light. So now where, if I produce this ray backward, again with the dotted line you show it to be passing through F. The ray which is parallel should pass through F. So this one is the light, dotted light. So where the image has been formed, the image has formed at F. So when the object was at infinity, the image is formed at F. And what can we say about the nature of the image? It is a point you can see here. So it is diminished and very small, we can say diminished or very small. And the second is, it is virtual and erect. The second case you can see here is when the object is between infinity and pole. This is the object which is not very far, not at infinity, but between infinity and somewhere between infinity and pole. So a ray of light which is coming parallel to the principal axis. Now again the same way, where it should go back in the same medium like this. But what we will do, we will produce it to make it look past through the focus. So I'll produce it. You, when you are again copying in the notebook, you do it with the dotted line. I'm showing it with any other color. So this is the ray of light passing through focus. But to get the image, what we should need at least two reflected light. And remember one thing, what the rules which we have done, the three or the four rules which we have done, either of the two rules you use to get the form image. So I'll take another rule which says the ray which is passing through curvature. You can see this ray of light. This will straight pass through the curvature. And the ray which is passing through curvature will retrace its path. So you will get an image here. You can see the 2 points where the reflected lights are meeting. So there you will get an image. So where the image is formed now, it is between pole and F. And what can we say about the nature of the image? It is virtual and erect. Erect. You can see the arrow pointing upward. So this means the image is erect. And it is virtual also, right? And diminished means smaller. It is, yes, of course it is smaller than the size of object. So based nature of the image form, now I can say what we have learned, a convex mirror always produces virtual and direct images, and the image is always smaller than the size of the object. So using this we can form a rule. This has convex mirror has number of application. First is it is used in rear view of automobile. It is used as rear view mirror of automobiles. You know, in the vehicles you can see the traffic coming from the backside. That mirror, the mirror in which you are seeing, that is called the rear view mirror, and it is convex mirror. It is a convex mirror. Another thing what you have noticed is the vehicle which are coming from behind, they appears to be smaller than the actual size, right? So that is one very important use of convex mirrors. Convex mirrors are used for security purposes. That means like in the ATM, when you are drawing the cash, you can check whether someone is behind you. So one kind of security it is providing you. The in the blind curves of the road and inside the buildings, the convex mirror are installed, especially in the blind curves when you cannot see a heavy traffic or a heavy or huge vehicle is coming. There, especially these convex mirror will be installed so that in order to avoid accident. Similarly, to avoid running into each other or to prevent the collision in the malls also, and in the hospitals also, these kind of convex mirror are installed. So now we are finished with the rules for the image formation in case of convex mirror and uses of convex mirror. So you practice all these cases, drawing carefully and properly in your notebooks. Thank you.